Hello friends, today our topic is the matrix multiplication with the zero matrix and also with the identity matrix. Now what is a zero matrix or null matrix? Already we know the zero matrix or the null matrix is practically a square matrix. Suppose we have a null matrix that is denoted by O, and suppose it is of the order 2, 2. That means the row is also 2, row numbers, and the column numbers are also 2. So all the elements of the null matrix or the zero matrix is containing as 0. So for the matrix multiplication for the zero matrix, if we have a matrix of order x, that means suppose we have a matrix that is capital X given here and it is of the order n, then we can multiply the null matrix also with the same order. So that means if it is on the left hand side, that means null matrix into the matrix A, it is also giving us the result as a null matrix, and that is also true if we have the X on the left hand side and the null matrix on the right hand side, the result is also giving the same, that means the null matrix or the zero matrix. That means if you were to multiply a zero matrix with another non-zero matrix, then you will get a zero matrix. Let's check if it is true or false. Here we have, suppose, two matrices, that is 1x, that is non-zero, that means 1, 2, 3, 4, and it is 2 cross 2. Once more, the null matrix that is also of the same order, that is 2 cross 2. So here first one we are looking the null matrix on the left hand side of the non-zero matrix. So O into X is giving us 0, 0, 0, 0 into 1, 2, 3, 4. So according to the properties of the matrix multiplication, we are multiplying 0 with 1 and 0 with 3. That is our first element. Then 0 with 2 and 0 with 4. Then the second 0 with 1 and 0 with 3. And then 0 with 2 and 0 with 4. So as we are getting the result as 0, 0, 0, 0, that means that one is a null matrix. So now we are checking the null matrix on the right hand side of the non-zero. So that means 1, 2, 3, 4, 0, 0, 0, 0. Now that is also giving the same as 1, 0 plus 2, 0, 1, 0 plus 2, 0, 3, 0 plus 4, 0, 3, 0 plus 4, 0. So that means we are getting the null matrix. So that means it proves that OX is also equal to XO, also giving us the null matrix. So any matrix when multiplied with the null matrix, we are getting a null matrix. So what happens when we have a matrix multiplication with an identity matrix? So identity matrix means, suppose I 2, that means it is of order 2. So we are getting the identity matrix like that. All the diagonal elements are 1. So if we multiply any non-zero matrix with the identity on the right hand side, obviously two of the matrices have to be in the same order. Then we are getting the non-zero matrix. Same as if we have the identity matrix on the left hand side of the non-zero, then once again we are getting the non-zero matrix itself. So let us check that is true or false. Let we have two matrices. The X is a non-zero matrix and it is giving us 1, 2, 3, 4, and I2, that is the identity matrix, that is 1, 0, 0, 1. So at first we are multiplying the identity matrix on the right hand side of the multiplication, that means on the right hand side of the non-zero. So 1, 2, 3, 4 into 1, 0, 0, 1. So 1 into 1 plus 2 into 0. 1 into 0 plus 2 into 1. 3 into 1 plus 4 into 0. And 3 into 0 plus 4 into 1. So we are getting 1, 2, 3, 4. That means the non-zero matrix X itself. Then we are multiplying the I2. Here that is written wrongly. So I2 into X. So on the left hand side of the non-zero matrix. So 1, 0, 0, 1 into 1, 2, 3, 4. Here we are multiplying 1 into 1 plus 0 into 3, 1 into 2 plus 0 into 4, 0 into 1 plus 1 into 3, and 0 into 2 plus 1 into 4. And obviously that is also giving us the result as 1, 2, 3, 4, and that is the matrix or non-zero matrix X itself. So we can say X into In of any order is also equal to the In into X, and we are getting the matrix or the non-zero matrix X itself, and that is the matrix multiplication with the zero matrix and also with the identity matrix.